This conference will now be recorded.
All right. First of all, thanks everyone for joining, and I hope everything is good at your end. So, just to give a quick introduction, my name is Adam, and I'm part of Wezva Technologies. So, before I jump into the subject, there are a lot of people who keep asking questions about the fundamentals of DevOps and where should I get it started. So I would just request you to go back and subscribe to my channel, which is DevOps Learn Easy. So try to get hands-on with all the basic and essential things which is needed for DevOps to kickstart. So by saying this, now why are we here? Now, pretty much if we see, every organization has started using containers for replacing their traditional deployments with modern deployments. So that instead of you doing all the work manually, so you create a image, and using that image, you will be able to quickly deploy your application. So it's easy to generate, and it's also easy to run, and you can scale it. Now, when we say containers, it's not easy when we try to scale, because we will be having a lot of machines on which it has to be maintaining. So that's when an orchestration system comes into the picture. And in the market currently, Kubernetes is one of the popular tools for managing or doing the orchestration of containers. And it is quite necessary for every one of us to be aware on how things work in Kubernetes. And not just that, it is quite essential that whenever something goes wrong, when you are doing a deployment of your application or your image in Kubernetes, how do we debug? Because Kubernetes, again, is one of the complicated subject. Okay, so when you are doing your day-to-day work, so if you are using Kubernetes, then you should be understanding that if there is a problem, in order to fix the problem, have a clarity on what exactly went wrong, so that with the help of it, you should know how exactly to investigate. So this is one of the requirement for every one of us, wherein you are a DevOps engineer in which you are focusing completely on Kubernetes. If not, you might be a developer or a QA or a support person who still continues to use Kubernetes in your day-to-day life. So in that way, what is that you need to know? So in Kubernetes, how does things work? And if it doesn't, the whole point of the agenda, what we are going to learn. Okay, so we'll try to understand how exactly we debug in case if there's a problem in Kubernetes while deploying, and for that, what are the different scenarios that we will face and how do we address it. So that's the agenda that what we are going to have. Okay, so by saying this, now before we jump into more of practicals, there's a little bit of concept that we need to, how a particular pod works in the Kubernetes cluster. Okay, so when you take a pod goes through different phases, right from the time that you execute kubectl apply and your YAML file, to the time where you say kubectl delete and the particular pod is getting deleted. Okay, so in a simple nutshell, when you say a pod, what are the different phases of the pod, and if it is working or not working, what are the different phases that you will be getting as a message from Kubernetes. Okay, again, I'm requesting everyone to go on mute, please. So now, these are the 6 important phases that will help you to understand and debug whether a pod is working fine or not. Okay, so what are these? Let's get a little deeper inside each one of them. So whenever, let's say that you have a manifest file, which is nothing but a YAML file in which you specify what and all is the requirement or the spec of your pod, right? So, okay. Am I audible to everyone?
Yeah.
Yes, yes.
Okay,
Yes,
cool.
you're audible. Yeah.
All right. So what happens when you try to develop a manifest file in which you will be telling what is the spec of your pod, like what image to take, what should be the startup command, and what should be the health check, and couple of all the other things that you need. Now, when you go ahead and say kubectl apply your manifest file, so what is the first thing that happens? Now, Kubernetes will try to see the spec what you have given, and based on the spec, it will find out whether any machine which is available in the Kubernetes cluster matches the requirement of what you have given, and then it will be assigning the pod to that machine. And only when the pod is getting assigned or associated to a machine, then the container inside it will get started. Okay, so from that way, if a pod is not being assigned to a machine, then the state of the pod when you say kubectl apply will be in a state called as pending state. Okay, so usually when you will be seeing this, when Kubernetes is not able to associate or assign the pod that you have just now applied to a particular machine. Okay, and what are the reasons for that? There are plenty of reasons, which is what we will be getting in deeper. But from a higher level, try to understand whenever you see a pod and the state of the pod says pending, then you need to understand that the pod has not yet been assigned to any machine in the cluster. Okay, so that's the first understanding that you should get. Next, assume that now Kubernetes was able to find a machine in which the resources is matching, and then the pod gets assigned. Now what happens after that? So once the pod gets assigned to a particular machine, or what we call it as a worker machine, then the container gets created. Okay, now however, there are various phases in which the container creation happens, because going back to the basic of container creation, if you are using Docker as the management for containers, then in order for you to create a container, first you need to make sure that the image is downloaded, and then from the image a container should be created. So that is where, unless and until a container is created successfully, if the pod is in still a state where it is downloading an image, or after downloading it is trying to create an image but it is not success, so in that case the state of your pod will be in container creating. Or in simple words, if you see a pod is in a state of container creating, so you need to understand that somewhere the pod has not created the container successfully. And once again, there could be various reasons, like the image is not getting downloaded, or the image is not available, or there is some problem with the container creation. So that is when we will be having this state. However, we will get in deeper into what that it is little later. Now, once the container is being successfully created, then the state of the pod will become running. So that's where once the pod gets assigned to a machine, and then image is downloaded, and then the container has been successfully created, then the state of the pod will become running. Sometimes in a pod, you might also be having more than one container. So in that case, at least if one of the container is successfully created and it has started to run, then the state of the pod is called as running. Okay, remember this. Now, there is another state of the pod which is called as failed. Okay, now there could be various reasons because of which a pod has all the containers terminated. Okay, so what will happen due to various reasons, like I was saying, if a container in the pod is getting stopped or getting exited with a non-zero status, because generally when we say, all right, guys, can you go on mute? All right. So what happens when a container is running? So usually it will be communicating to the Kubernetes. Now, anytime if it returns a non-zero status, then it means that there is a problem. And whenever a status 0 is written, then it is indicated that everything is fine. So this is where now if a container has been stopped or exited with a non-zero status, then the status of the pod will be failed. Okay. Now, there is another state called as unknown. Now, this is one of a weird situations where there could be some kind of network issue because of which the Kubernetes master is not able to communicate to the Kubernetes workers. Now, because of that, what will happen? The kubelet component will not be able to receive any of the information about the worker or the different objects that we are running. So in that case, if you see the state of the pod will be unknown. So whenever you see that the state of the pod is unknown, then immediately you need to understand that there is some problem in terms of network, or there is some problem in communicating between the master and the worker nodes. Okay. And finally, for any reason, if you are deleting a pod or a pod has been getting deleted by any kind of API calls, then the state of the pod will be terminating. Okay, so as soon as you see terminating, then you need to understand either a user has called a termination of the pod, maybe by saying kubectl delete and the specific object, or there is an API call which has been done by another object or by Kubernetes itself, using which the pod is getting deleted. Okay, so in that case, the state of the pod will be terminating. So in a high level, these are the 6 states that you would be seeing whenever you're using Kubernetes. Okay, but the next question comes is, how do we see? And that's where, when you are trying to do a troubleshooting in Kubernetes, especially to troubleshoot a pod, so these are the 4 useful commands that you will be using day in and day out. Okay, so which is the kubectl get pods. So usually when you execute kubectl get pods, it will be showing you the list of all the pods available in your current namespace. Okay, and that's where whatever the 6 phases that we just now saw, you will be getting the output of that. So by executing the kubectl get pods, you will know what is the exact state of your pod. Same way, if you want to have a deeper details about what exactly is happening, then you can also use another useful command, which is kubectl describe the pod. So now when you say kubectl describe, in addition to the pod phase, it also gives you a bunch of information about what are the events happening in your pod. So when I say event, what exactly is happening? Because just by looking at a pending state, or just by looking at container creating state or running state, we will not be getting all the information. So sometimes you might need a little more deeper information. Then go ahead and say kubectl describe pod and the pod name. Now, for certain scenarios, your pod would be fine, but the container or the application inside the container might not be working fine. So for debugging those kind of scenarios, you would be using another useful command called kubectl logs. Okay, so the kubectl logs will help you to see whatever is the console output that has been given by the application or the container. So using which you will know if a container is getting stopped or getting killed, what is the last set of commands or last logs that is being given. So that is again something useful for us to debug. And at last, sometimes there would be a requirement where you have to go inside the container and then debug, because I want to check whether some particular file is available, some particular process is running. So if you want to debug any of those, then you should be going inside a particular container. So that's when you would be using the kubectl exe command, wherein by default, we know that every pod will have one container. So automatically, when you say kubectl exe and the pod name, you will be going into the default container that you have, or what we call it as the main container of your pod. Okay, so this is how, using this fourth command, you will be able to go interactively inside a container and you can do the debugging. And do we have to use all these? So it's completely based on the scenarios. So we need to first understand what are the different problems that we are going to face and what are the different set of commands or a combination of all these things which should be required. And that's, once again, is what we will be doing. Okay. So with this basics, let's first understand and see how the different phases of our pod looks like, which is the sixth phase that I was talking, which is pending, and then container creating, and then running and terminating. Okay, so just to show you what I'm going to do, I already have a Minikube cluster with one machine. So I have a default Kubernetes manifest file that I have written, which will have just a single pod to run. So we'll quickly try to run this and see how it is going to look. Okay, so let me connect. So this is my Kubernetes Minikube cluster. So you can see I have one machine in it, and if I just say kubectl get pods, so I don't have any pod running in my default namespace. Okay, and to show you this example, so let's take the first example where here all I'm doing is I'm trying to create a pod called as test pod, and for that I'm using image Ubuntu, and the container here will just run a simple shell script which will be printing my name for every 10 seconds. Okay, so this is what I want to do. But in order for us to see the state of the pod quickly, let me open another command prompt, and what we will do, so typically now here, I'll go ahead and say kubectl get pods, and along to this, I'll add a option called watch. Now this will be displaying you what exactly are the pods state. Okay, and side by side, we will now try to apply this YAML file. Okay, so just watch this first box. All right, so let me just say kubectl apply -f and pod status.yaml. So you can see, as soon as you apply, the first thing that happens is the pending state, where Kubernetes finds whether there is a machine available in the cluster which matches the requirement or which matches the spec what you have given. And as soon as it finds the machine, then it assigns the pod to that machine, and inside that the container creation process will happen. And that's where you can see the next state is container creating. Now in this, what happens? The image will be downloaded, in this example, the Ubuntu image. And once the Ubuntu image is downloaded, the next thing it will do is try to create the container out of the Ubuntu image. Okay. And in that, whatever the first command that you have executed, it would be calling that. Okay, and this is where, until the container creation is not successful, the state of your pod will be container creating. And once the container has been created and your startup command, whether there is a default command in the image or something explicitly like what I have given, runs, then the pod state becomes running. So which is where right now in our pod there is one container. So that container is also running, and the application or the first command inside it is also running, and that is where the state of the pod is called as running. And here, if you want to have a look at the details of the pod, now this is where you can simply say the other useful command that I showed, kubectl describe pod, and the name of my pod is test pod. So it gives you a bunch of output. However, if you look at, okay, let me rerun it. So if you look at the last couple of lines, okay, looks like the screen problem. Okay, so if you look at the last few lines, it gives you the details about events, which is where the describe command is very useful. So you can see now, the first thing, when it was in a pending state, it was searching for the machine. So it is assigning, or the Kubernetes is assigning the pod to a machine. And then the state becomes container creating. Now, during that phase, you can see that the image is being pulled and it is trying to create a container and start the container. Okay, so until here, the state will be in container creating. And after this, when the startup command is successfully executed, then the state of the pod becomes running. Okay. Now, same way, what I will do, let me go ahead and forcibly delete this container. So that means I am invoking a API to delete. So that way, if I say kubectl delete -f and the same YAML file, you can see now the state of the pod becomes terminating. So this is where, if either you have invoked or for certain reason any other object has invoked the API for deleting the pod and the container inside it, then the state of the pod is called as terminating. Okay. Now, however, I'll not be able to show you the unknown phase because for that there should be a network issue. But let's try to create all the remaining scenarios. Okay, fine. So quickly, as we just saw, so there are different phases wherein a pod will be in pending state or a container creating or running or terminating. So this gives you a very high level idea on what is the state of the phase. But what we have to learn next is, in each of the state, if there is a particular error, how do we debug? Okay, so that is what we need to learn a little deeper. Okay, because now when I say pending state, what and all are the different scenarios for which the state will be pending? And the same way, there could be a container creating state. Now in this, it's not that always you will have one image, you will also have multiple containers that you want to create, and for that there might be multiple images. So what will happen? One image might be downloaded successfully, however another image might not be downloaded, or it might be still downloading, or there is an error. Still it calls it as container creating, because unless and until all the images needed for the pod is downloaded and all the main containers needed for the pod is created, the state will be under container creating. Okay, so that is what we need to know. All right. So what is the next thing that we are going to do? Now this is where, let's take phase by phase. Okay, and again, guys, it will be great if everyone goes on mute, because every time if I mute everyone, there might be some small glitch. Okay, anyway, so now we understood from a very high level what are the different phases of the pod. But now let's get a little deeper on how do we debug in case if a state has been displaying from a longer time. So that's where we need to investigate. So if you go ahead and do a kubectl apply and you see that when I say kubectl get pods and it always shows me pending pods or the state of the pod is pending, then there are various scenarios for which the pod might be still in pending. Okay. Now, considering the most popular scenarios, these are the 5 scenarios for which your pod will be in a pending state. Okay. So what are they? Now, the first scenario is there could be because of a resource crunch. So what do you mean by resource crunch? So you want a pod to be created with certain amount of RAM or certain amount of CPU to start, but that capacity is not available in any one of the machine. Then you will be seeing this resource crunch. Same way, now if in Kubernetes, there is no machine matching the requirement what your spec is telling, then the second scenario of node unavailability will be there. Okay, I repeat, please mute. And then the third one is whenever you are using a persistent volume for your pod, and if that persistent volume or the claim is not available, even then the pod will be in a pending state. And in the same way, now when you try to create your pod, the first thing that you have to do is the namespace in which the pod is going to run, you are going to set a resource quota. So in case if your resource quota is being reached or you are trying to overshoot the resource quota, even then you will be getting the state called as pending. Okay, so these are the different scenarios that we will have to understand. Okay, so let's try to mimic these and we'll see all the scenarios one by one. So what I'm going to do, I'm just going to take a simple example for each one of them. All right, now let's take the first one, which is resource crunch. Now before that, let me just quickly show you a sample YAML file. All right, so let me go to all right, so we are talking about pending pods. So let me go to pending pod. And in the pending pod, let me take the first example, which is resource crunch. Okay. Okay, so here I'm trying to create a pod. Once again, it's the same pod with Ubuntu image, and I'm running my name for every 10 seconds. Okay, so this is just a simple pod and a container, but I'm trying to tell that whenever this pod has to be created, I need a resource, and specifically, I need certain capacity in terms of RAM. Now, this is where the basics of your Kubernetes comes into the place. So anytime you are going to create a pod, you can specify a resource. And anytime when you are specifying a resource, whether it could be RAM or CPU, so there are 2 values that you have to give. That is minimum and maximum, right? And that is what technically in Kubernetes we call it as request and limit. So just to help you, request is the minimum capacity that is needed for Kubernetes to assign the pod to a machine. Okay, so in that way, what I'm trying to tell is, in my cluster, I want this pod to be assigned to a machine which has a minimum of 4 GB. And when the pod starts running, the maximum that I want to allow the capacity for this pod to be utilized is 6 GB. So this is where now, if in my cluster, if I do not have a machine which has minimum of 4 GB, then your state of the pod will be pending. Awesome. Okay, guys, I think I have to repeat again. Please mute yourself. Thank you. So now here, again to repeat, if in your cluster, if Kubernetes cannot find a machine which doesn't have minimum of 4 GB as of now, then the Kubernetes cannot assign that machine. Okay, so in that way, right now, we have only one machine in our cluster, which is the Minikube. And because of that, both this machine acts as the master and the slave, okay, or the worker. And in this machine, if you see, I have a total of 3.9 GB. And currently, all I have is around 1.7 GB. So because of that, when I try to apply, Kubernetes cannot assign this pod to any machine because there is no machine in this cluster which has 4 GB of capacity. Okay. Now, this is where let me go ahead and do a kubectl apply and we will see what is the status. Okay. So again, for this, I'll put this watch, and meantime, what we will do over here, let us go ahead and say kubectl. Okay. Apply -f and this YAML. Okay, and quickly, if you go back and see, the state of the pod is pending. Why? Because the resource required for the pod to get assigned is not available. Now, this is where, how do I debug? Because since I'm telling you, you will be aware, but if not, when it comes into the pending state, the next immediate thing what you have to do is use the kubectl describe command and see what is happening. Okay, now let me go back to the first screen. All right, so here, if I go back and just say kubectl describe the pod, and it's the same test pod. Now, I don't want all the output, so pretty much I'll just take the last 15 lines of my output. Okay, and here you can see the event. So the event is completely stopped in the first place. So here it clearly says we have totally one machine in our cluster, and out of that 0 machines are available matching the spec what you have given. So that's where it says insufficient memory. Okay, so this is the first scenario where you specify in your pod that in order for the pod to get assigned, the resource minimum requirement, if that minimum requirement is not available in any of the machine in the cluster, then you will get the resource crunch. Okay. Now, let's look at another example now. Okay, now how do I fix this? The only thing I have to make sure is we need to add more machine to your cluster, or any of the existing machine that you have, you need to make sure that more resources, that is more RAM or CPU, is added to that machine. But technically, if you are using a cloud machine, then what you have to do is make sure you add another bigger machine into your cluster which has more capacity needed for you. Okay, so that's where the first problem is resource crunch, where the spec, whatever that you have defined, doesn't match with the existing capacity. Then Kubernetes will say the state is in a pending state. All right. Now, let us look at the next example, which is node unavailability. Now, what are the scenarios that you have for node unavailability? Like I said, there might be a couple of machines that you have in your cluster then all of them are being utilized fully, or we have a concept called as affinity or node affinity in Kubernetes. The need for that is when you have a cluster, what happens is Kubernetes, you can specify which particular machine in the cluster you want the pod to be assigned. Because by default, when you just say kubectl apply, Kubernetes will take any random machine matching the capacity what you have given. But instead, there might be certain reasons where you want the pod to be assigned or created on a particular machine in the cluster or a particular group of machines in your cluster. And that is where you will be specifying what is the exact machine in which the pod should be getting created. So in that way, when the machine itself is not available matching your requirement, then the pod will still be in the pending state. Okay. So to understand this example, okay, let me go back, and I have another example here, which is node unavailability. Okay, so let's try to see what I'm going to do in this. So it is the same pod that I'm going to create, but this time, instead of giving the resources of how much I want, all I'm trying to tell is in the cluster, I want to create the pod only on those machine which has a label. Because again, if you go back to the basics of Kubernetes, every object, including your node, can be uniquely identified by a label. So that way, assume if you have a cluster of 10 machines, but out of that 10 machines, I want my pod to be created only on a particular machine or a group of machines in which the label is applied. Now that's where what happens if Kubernetes is not able to find a machine matching your label, then it will be still in the pending state. So this is another kind of situation where if the label that you are giving doesn't match with the node, or if there is no node available to assign the pod, then your pod will again be on the same pending state. Okay. Now, for this, what I'll do, let's go ahead and once again apply this. Okay. Now, before I apply, let me just try to remove in case if there is a label. Okay. So, okay, to see the nodes first, I'll say kubectl get nodes. And what I'm doing right now is I am removing a label if it is existing from a node. Okay, so that I can show you this example. Okay, node, the node name, and the name of my label is my node. Okay, so I have removed the label. Now, in our cluster, there is only one machine, and that machine doesn't have this label. So if I apply this spec in my cluster, Kubernetes will not be able to find the machine which is matching this label. So it will still say that no machine is available in the cluster. Because of that, the state of the pod will be in pending. Okay, so once again, let me go back and clear the screen. I'll put the kubectl get pods, and now let me run and apply this. So kubectl apply -f and this example. So quickly, if I come back, so you can see the state still says pending. Okay, and now to once again see what went wrong, you have to use the kubectl describe command. So I'll go back to the first screen. I'll clear the screen here. And again, for all the examples, I'm using the name of the pod as test pod so that it's easy for me to run the command. Okay, so I'm once again trying to run the same kubectl describe command for this pod, and I'm just taking the last 15 lines of the output. So once again, you can see it clearly says that out of one machine in the cluster, there is no machine which is matching the affinity or the node selector, because there is no such machine in your cluster which has the label matching your requirements. Okay, so what we will do for this, we will now apply the label, and then you can see immediately the machine will be created. But until then, the pod will be in the same pending state. Okay, so what I'll do for this, I'll just move this a little up, and I actually don't need last 15 lines. I'll just take the 10 lines, but I want you to continuously see this also, because when I apply, this will also get changed. So what we will do, I will run this command itself in a watch command. So what I'll do, I'll use the Linux watch command, and I'm going to run this kubectl describe command every 1 second so that you can see live output. So kubectl describe pod test pod, and let's tail it. All right, so you can see this will be displaying the same command, or it will be running the same command every 1 second. So now side by side, what I'll do, I'll quickly do this apply here so that you should be seeing. Okay, now I'll just keep it here, okay, so that you can see the output. So we will say kubectl label. Okay, so what I'm trying to do is apply the label on this particular machine. So I'm going to say kubectl label node and the node name, and what is the label I want to apply. So the name of the label which we have given in our manifest file is my node equal to demo node. So this is the name of the label and its value, and the same thing is what I'm going to do, my node equal to demo node. Okay, so now as soon as I apply, you should immediately see that the Kubernetes will say that I found one machine, and the state will get changed from pending to container creating, and then the image download and the container creation will happen. Okay, so just watch. You can see the label got applied. Immediately Kubernetes picked up the machine and assigned the pod to that, and because of that the state got changed, and then further the image download and the container creation happens, and when the container is successfully started, you can see the running state. Okay, so this is another scenario where your pod will be still in pending state. Okay, right, so let me quickly delete it. Okay, where is this? So whenever I delete the pod, you can see it gets the status of terminating, right? Okay, so what we have seen is the second scenario for pending state. Okay, now let's come to another pending state scenario. As I said earlier, now in Kubernetes, there is a concept called persistent volume, and pretty much I believe everyone are aware. If not, if you need certain data to be shared to the pod again and again during runtime, regardless of where the machine is going to be created in the cluster, then you need to create the shareable folder as a persistent volume, so that this persistent volume can be stored in cloud like AWS and Azure. So whatever you store into your container will actually be stored on the storage created by AWS or Azure. So that way, that volume which you are sharing from your pod or container to the cloud is called as persistent volume. Now, when you are creating a pod, so let's say an example in which your application files or logs you are trying to store into a shared folder like persistent volume. And for that, first you need to make sure that the persistent volume is available. And okay. Okay, problem here is the app is not allowing me to mute everyone every time. Anyway, so the point that I was trying to tell is when you have a requirement to use persistent volume inside your pod, then you need to make sure first there is a persistent volume available in your cluster. But if you go back to the basics, what we have learned, how do you use a persistent volume? First, you need to create a AWS storage. For example, if you are using AWS, and in that for the storage, you can use EBS volumes. And that EBS volume can have a capacity of 10 GB or 100 GB. Now, that we have to map to our cluster and create a persistent volume object, which is first step. And the second step, what you have to do is, you will not be directly using the persistent volume because there will be a pool of persistent volumes available. And during runtime, in your manifest file, you are going to use what we call it as persistent volume claim. So claim is nothing but the policy where you will say for your pod, how much of capacity or storage that is needed in a folder to mount. So that is where when you create your pod in the manifest file, you will only tell the details of the claim. However, in the cluster, the Kubernetes will check based on your claim, is there any persistent volume available or a storage available matching the requirement? And for that, it will assign the pod, and whatever you store in your pod will go to that particular persistent volume matching the claim. So this is where the next scenario here, what we are going to see, in case if the claim is not able to find a persistent volume which matches your requirement, then still the state of the pod will be in the pending state. Okay, but to solve this, you need to first identify whether it is because of the persistent volume, and then you need to talk to the administrator, or if you are the maintainer of the cluster, then you need to add more persistent volumes or increase the size of the existing persistent volumes. Okay, so this is another scenario that we will see. Now, to see this, let's take the next example. So I might be just switching screens, so please bear with me. Okay, it's not possible to just show everything in one screen. So let's take the next example, which is the persistent volume unavailability. Okay, so right now in this machine, if I want to, or in this cluster, if you want to see what are the persistent volume available, now you can just say kubectl get pv. You can see I don't have any persistent volumes. Now purposely I'm doing it because only then you will get this error, correct? Same way, there is no persistent volume claim also created. So if you look at the definition of my manifest file, okay, so what I'm doing here is, so this is where again you should go back to your classes, what we have learned and the basics. So first thing, I'm creating a persistent volume claim, and in the claim I'm telling that I need a storage of 10 GB. So like a policy, if I need 10 GB, then I will use this claim. Okay, and the name of the claim is my EBS vol claim. And remember, there is no persistent volume available here, but I am trying to tell my pod to use this claim, and try to get a storage of 10 GB, which is where the claim will try to check in the cluster there is no storage available, and because of that your state itself will be in the pending state. Okay, now if you come down to the pod definition, so all again you have to brush up your basics what we have seen in the class. So now if you see, it's the same pod example, but what I have done, I'm trying to tell that I need to create a volume associated to the pod, and for that I'm going to use the persistent volume claim called my EBS vol claim. Okay, and if this claim finds a persistent volume available in my cluster which matches 10 GB, then that folder or that volume will be mounted inside my container under the folder called temp persistent. So then what will happen? Whatever I'm storing in this pod under the temp persistent folder will be stored into the AWS or Azure, whatever that you're using for your persistent volume. Okay. So when I apply this, what will happen? Kubernetes will try to first check before assigning the pod, do I have a claim matching my persistent volume claim? And only then, if it finds a claim with respect to the persistent volume object, then the pod will get assigned to a machine. If not, it will be still in the pending state. Okay, so this example is all just to show you that for my pod, I'm telling a claim, and this claim says check in the cluster whether I have a persistent volume object or a storage which has 10 GB. If it is there, then mount it to this folder in the container. All right. So once again, you can see here, I do not have a claim created so far, or I do not have any persistent volume objects available. So now let me go ahead and say kubectl apply PV. Okay, so here you can see I have defined and created a persistent volume claim and then my pod. Now because of this, if you go here and just say kubectl get PVC, you can see that there is a claim, but the claim is in the pending state. That is because it is not able to find any persistent volumes available. Okay, and how do I debug? And this is where if you go back once again, you can see the state of the pod will be in pending, or let me clear and show you once again. Get pods, you can see it says you need one container for your pod, and before that the pod itself is in a pending state. Okay, and how do I find out what exactly is the issue? So once again, you have to say kubectl describe pod and the pod name. Okay, so now look at the output. So this is how your kubectl describe is very, very useful. Okay, now once again it clearly says before assigning the pod, there is no such pod in the, there is no such machine in the cluster where it's not able to match the claim. Okay, so in order to solve this problem, what you should be doing is you need to first find out what are the available persistent volumes in your cluster, and depending on your requirement, like what you have given in the claim. So if my claim is 10 GB, then I need to make sure that my cluster has a persistent volume object with minimum of 10 GB, or we need to create more persistent volumes and then you have to add it to your cluster. Okay, so that's where it's about the capacity, once again, what is needed, or the claim which is needed for your particular pod. Okay, so this is another scenario where your pod will be in a pending state. All right. Anyway, I put everything into one manifest file so that everything gets deleted. All right, so let me clear the screen. I'm sorry for that. All right, so now let's look into the next scenario of the pending, which is where the resource quota comes in. Okay, again, let's go back to our basics. So when you're learning Kubernetes, it is not just about learning pod or deployment. Now we know the basic that every pod or an object that you're creating in Kubernetes will be within a namespace. So namespace is basically a group of all the objects, right? Because you will not just directly say kubectl apply anywhere you want. Because right now we are using the default namespace, but when you go to an organization in real time, you should first create a namespace, and under that you will be running this. And in that, when I say a namespace, so there will be different namespace with respect to different projects. Now, you need to allocate a proper resource quota. So when I say resource quota, again, the basics, what is the maximum capacity that you want to allow for that namespace so that all the objects inside that particular namespace should use within the quota. Okay, so that is where now in real time, when a cluster is created, we will create a namespace for your application or your product, and then we will be setting the resource quota. So there will be some scenario where the resource quota is being set. However, when you are trying to create some pod inside that namespace, you are trying to overutilize, or you are going to go beyond the quota specified. So in those cases, again, the pod will not be created properly. Okay. Now, sometimes the state of the pod might not also show you pending, but still it is part of the pending, because unless and until the pod is not being assigned to a machine, all the state is generally considered as pending. But now let's try to see this unique scenario where sometimes the state will not be even displayed as pending. So we need to understand what is the reason for the failure in this. Okay, so to understand this, what I'm going to do is have a YAML file here. Okay, and this is where, if you see, where are we running? So right now we are using the default namespace. So this way, in a real time, you will be creating a namespace, and inside that you will be running. Now for this demo, what I'm going to do, I'm going to set a resource quota for my default namespace itself. Okay, and that's where, let's take this exceeding quota.yaml. All right, now it's a little lengthier example, but try to understand. So first, I'm trying to create an object wherein I'm trying to create a resource quota object, and I will apply this to my default namespace. So what I'm telling here is, in my namespace, the maximum that I'm going to allow utilization of CPU is 400 milli CPU. Okay, this is just for example, but in real time, you will not be setting so small. So it depends on what is the total capacity in the cluster, and for your application, how many or how much of capacity needed. Okay, so just to show the example, I'm going to put a resource quota for the default namespace, where no matter how many pods you create within the namespace, the maximum utilization of all the objects of the pod within this namespace should not reach beyond 400 milli CPU. It should be either equal to 400 milli CPU or below that. So that is what resource quota is. Once again, resource quota is nothing but the total utilization of all the pods in a namespace should be equal or less than that. Okay, so that way, when I apply this, we will be applying this resource quota, which says maximum of 400 milli CPU. Now, let us look at the actual definition of your pod. And this is where I want to create multiple copies of my pod. And that's where, instead of giving as a pod, I'm using the object as deployment, because I need the replication for my object. So In this example, I'm creating a deployment object, okay? And for that, I'm saying I need 3 replica, okay? And all the others are basic definition, but the important one I want you to see is here. So it is the same container that I want to create, which will be printing my name. But for this, I'm trying to tell I need a resource for the container with a minimum of 200 milli CPU. Okay, and when it starts running, maximum I can allow is 400 milli CPU. But this will happen only when this container is running. The maximum we are going to allow is 400. But for creating this container and assigning this pod to a machine, I need a minimum of 200 milli CPU. So this is where, if you now see, my deployment object has 3 pods, and each pod needs 200 milli CPU. Okay, so when I apply this, what will happen? My cluster has capacity for 200 milli CPU, but I need 3 replicas for this object. So this object alone needs 3 pods, which is nothing but 3 into 200 milli CPU, which is 600 milli CPU. And eventually, in the namespace where I'm going to apply, which is the default namespace, what is the quota that I've given? The quota itself is 400. So because of that, the object that you are creating will try to create 3 pods, which needs total of 600 milli CPU, but the resource quota will say I will not allow beyond 400. And that's where, let's see what would be the message. Okay, now for this, once again, if I just say kubectl pod, get pods watch, and let's go ahead and apply kubectl apply -f, and I'll say exceeding quota. Okay, exceeding quota. So right now you can see what happened. It moved from pending state and it created a container and it is running. But how many pods? Because now if you understand, we are not creating 1 pod. We are actually creating a deployment object, and that has 3 pods definition. And this is where now you will not be seeing this status because you didn't create the pod directly. So what object did we create? We created a deploy object. So you should say kubectl deploy. Okay, and now when you say kubectl deploy, you will see that out of 3 replicas or pods what you want, only 1 is updated, which is where, once again, to debug you will be using the kubectl describe command, but instead of describing the pod, this time we have to describe the object that you created. But if you try to say kubectl describe the deployment object and the name of the object is this, you will not get much information here, because at the end, if you see, your deploy or the deployment object is going to create another object called replica set, and the replica set is the one which is actually creating the pod. So that way, now you should be looking at the output of the replica set. Okay, so for this, once again, quickly to show you, deploy, and now if you say rs, which is nothing but replica set. So now you can see you created the deploy object, and this deploy object has created the replica set, and this replica set is what is actually going to create the pods. And in that, it is saying you need 3 pods, which is your desired number of replica, but however only 1 is there. So what happened to other 2? So to know that, once again, you should be using the kubectl describe command, and for this situation we will describe this object. So replica set object and the name of the replica set. Okay, and now see the output. So it very clearly says that your replication controller or the replica set is unable to create the remaining replicas, because the quota that you have given for your namespace itself is 400 milli CPU. As soon as one replica got created, there is no enough resources for creating the next two. Okay, because even though you have 400, it doesn't mean that exactly it will be taking 200. There is 200 milli CPU plus a little more something is taken. So that is where in your current namespace, you do not have a capacity to create more than one pod. And the error is now because of the resource quota what you have applied. So to solve this, what you have to do, you need to first understand how much is the actual capacity that is needed for you, and does your namespace has a proper quota? If not, you should increase the quota of your namespace. Okay, if not, that could be a situation where your cluster itself doesn't have a capacity, because of which your resource quota is limited. So then what you have to do, you need to add some more capacity to your cluster by adding another machine, and then increase the resource quota of your namespace, and then you run. So this is where, before running your object or Kubernetes deployments, you need to first understand, for every object that you're running, what is the capacity needed, how many replicas you are trying to run, and what is the namespace in which you are going to run this, and what is the resource quota needed for that namespace. Okay, so simply learning Kubernetes is not blindly that you run two commands, kubectl apply, create a pod. No, you need to know all these things, because only then your application will start running. So it is quite necessary that you need to first understand what is the capacity needed for your application, which you are defining through your pod, and which namespace it is going to run, and what is the quota that you're allowing. Okay, so that's where the other type of pending, because even this is called as pending, but however, if you see, you should not be looking at directly the pods, but instead you should be looking at the parent object that it created. So in our case, it is the replica set. Okay, so this is another issue. All right, now let me just delete it quickly. So anyway, I've deleted my quota and I've deleted everything. Now, just to show you, what I can do is, suppose if I have a proper quota, okay, let me just show you. So I'll quickly, put it as a new file, vi-fix.yaml. Now, here, I'll keep the same quota, but this time what I will do, I will say I don't need 200. So I'll say all I need is just 50 milli CPU. Okay, so that's the only thing I need. So this way, if I go ahead and say kubectl apply -f. Okay, now let me just show you here also. So you should see all the replicas getting created. Kubectl get pods. Now quickly, let me say fix. And now if you come back, it should be creating how many pods? Once again, it says only one pod. Why? What happened to the other pod? You need to see the reason. So once again, kubectl get rs. So again, it says the same, because the resource quota is not defined properly. Describe rs. So the same problem. So the limit you have not set up properly. So you have given it as 400. So this way, either I should be clear on what is the capacity that I need. So based on that, we should be setting it properly, or I should be increasing the capacity quota that I have given for the namespace. Okay, So that's what you're going to do. All right. Okay. So here again, we are talking about the resource quota, right? So your namespace will have a particular resource quota, and you are trying to use the capacity beyond it. So that way, either you should be adding more resources, or you should be increasing the resource quota, what you have given as the limit. Now, there is another scenario in the same namespace called as limit range. Again, it is the basics, because when you learn Kubernetes, it's not just the pod, you should also be knowing what is the limit range. So whenever you create a object or a pod within a namespace, you can also set what is the default minimum and maximum capacity needed for the pod or the container to run. That is where the limit range object comes into the picture. So sometimes what will happen, in the namespace, even though you have a quota, you cannot just allow user to use any capacity that they want. Okay, for example, if you saw in the previous example what we had, my capacity for the quota was 400, and every pod I had given 200 to 400. So randomly, you cannot allow users to create a pod with any capacity they want. So that is where you can define what will be the range of values that you should allow users to create a pod within a namespace. Okay, and in case if the user is exceeding, this is where it's not about creating one pod and then the remaining is going to be failing like what happened here. We can exactly stop the user in the beginning itself and say, hey, your capacity requirement is not at all matching, so I will not even allow you to create the object. Okay, so for that, let us look at the next example. So I'll take this exceed limit. So again, for this, I'm using a new object to show this example. Okay, so in this example, I'm trying to set a range of memory within my namespace. Again, it will be applied to my default namespace. So what I'm trying to tell is the minimum usage of a container or a pod should be 500 MB. However, each pod or the container can use maximum of 1 GB. So this is what I'm setting the range. So when a user is trying to define his object or a pod, if he doesn't give a value, then this will be set as the default minimum and maximum. However, if a user is defining his own capacity, and that if it is doesn't apply within this range, then Kubernetes will straightforwardly say that this capacity is not matching the range what you have given. So that is where, if you look at this example, I'm simply creating a pod in which I'm going to have a Nginx image. Okay, and in this Nginx image, I'm trying to tell, for me to assign this pod to a machine, I need a minimum of 800 MB. But if my pod is running, the maximum that I will allow to the pod is 1.5 GB. Okay, sounds good. But like the previous problem happened, if you have multiple replicas, then what will happen? It will create one replica and the other replica will not be created. So instead of that, if you apply a limit range, then you will get an error in the beginning itself saying your spec of the object is not valid, okay, or it is not within the range. So sometimes if you have given some values which is not within the range which administrator has set, then when you try to say kubectl apply, you will be given an error. Okay, so let's try to run this and see. So if I say kubectl, okay, before that, let me clear the screen and I'll do a kubectl get pod. All right, and then here, let's say apply -f, and we'll say exceed limit. Okay, so this time you can see the object itself is not created. Okay, now this is another scenario as part of the pending itself, because when you're trying to apply, Kubernetes doesn't even consider this spec at all, because it very clearly says that your values is forbidden. Okay, the reason is the range of value which is being set by the administrator using the namespace quota or the limit range is within 1 GB. And what you are trying to say is you are trying to tell Kubernetes to create a pod which will have a maximum of 1.5 GB, right? So logically that is not possible. So that's where it is trying to give you an error in the beginning. So anytime if you get a message like this, then you need to know what is the limit range or what is the minimum and maximum capacity utilization which is set for a namespace. So once again, all of them are namespace level. Okay, which is where you need to know. So once again, it's not just about creating a pod. So you need to know what your application uses, and for that, on the Kubernetes administration, what is the minimum and maximum that has been set. Okay, so you have to change that accordingly. Suppose if your application really needs 1.5 GB, then you need to change your limit range values. That is what should be the maximum. You have to change accordingly. Okay, so this is another scenario. Okay, kubectl delete. Okay, right now if you see there is no objects created, so there's nothing to delete because here nothing has been created. All right, fine. So what we saw is what are the different scenarios for which your pod itself is not assigned to a machine, or the pod itself is not getting created. So that's where the pending state of your pod comes into the picture. Okay, now there is another type of scenario where now assume your pod has been assigned to a machine wherein there is enough capacity matching your requirement, or there is enough machine to assign your pod, or whatever the prerequisite that is needed, like the persistent volume, is already available. Okay, so now when all these things are available, your pod will be assigned to a machine, and then the next state of the pod will move into container creation. So now let us get a little deeper into what are the issues that you will face during the container creation. Okay, now that's where I have grouped them into some of the common scenarios. So there are two major scenarios in which the container creation step will be failing. Okay, now one is called as image pull back off, the other one is called as mount volume failed. Okay, now let's try to get in a little deep. Okay, I'm just muting. All right, so now we are moving from our first problem to second problem, wherein let's assume that pod has been assigned, and now pod says that it is in the container creation phase, and at that time you see there is a problem. Okay, so how do we debug? So let's take the first one. So what happens in the container creation? I told you two steps, right? So the first step is it tries to download the image. Okay, now this is where there are two common scenarios for which the container image downloading, or what we technically call it as image pull, fails. Okay, because now where do you store your images? So ideally, there will be something called as a registry or a Docker registry. And in an organization, you will be having a private Docker registry. Okay, you will not be using Docker Hub. So you will be using either ECR registry if it is AWS, or you will be using a Azure registry in case your cloud is Azure. If not, if you are using some in-house tools like JFrog Artifactory or GitLab, they also provide some kind of container or Docker registry. Okay, so now in real time, when you go through your pipeline like CI/CD, you will generate the image and you will be storing it in a private registry. And your Kubernetes will try to pull or download the image from that private registry into the cluster, and then it will try to create the image. So in that way, the common scenarios where it will be failing is if there is a network issue, then your image download will not happen. Okay, which is one very common scenario that you will face. At that time, the message that you will be getting from the pod is image pull back off. So immediately you should understand, okay, if this message is coming, either the download is not happening because of a network issue, or there could be a wrong name of the image. Because when you say an image, going back to our basics, what we have learned, or if you go back to the channel and see the Docker basics, in the image generation, we would have understood a name of an image is a combination of two strings. One is repo name colon tag name. Okay, so now if you have done some mistake wherein you have not given the proper repo name or the proper tag name, then the Kubernetes will not be able to download the image, and then you will be seeing this message will be coming. So let's try to create this scenario. So now pretty much I've done with these examples. So let me go back to the next one, which is container creation. All right, so here let's try to take the image pull back off example. And this is where I'm just going back to the same example of running my name using Ubuntu container. But now watch, I'm trying to use a tag name called Ubuntu 12. Okay, so ideally, now from where I'm downloading, since I have not told any registry, so far for all the examples, the default Docker registry is dockerhub.com. So now, if there is an image called Ubuntu:12 as the tag name available in dockerhub.com, Kubernetes will work. If not, you will get this error. Okay, so to understand this, let's run. So now you can see there is a pod watch. Now watch carefully. I'll try to run kubectl apply -f and image pull. Now this time, what and all happens? Kubernetes was able to find a machine because I have not given any resource. So it just found a machine, and then it went to the next step called container creating. And this is where it is trying to download the image, but the image is not going to be available because you have done a mistake in the image name. And that's where it gives you a message called image pull back off. And to see this, if you just go back and say kubectl describe pod, and again I'm using the same name of the pod, and I'll just say tail. Okay, so you should see that it says that the pod is unable to download this image from the default location, which is Docker Hub, okay, or whatever the registry you have given. Now because of this, you can see that image pull is failing, and it gets into a state called as back off or image pull back off. So this is where whenever you see this message, immediately you need to understand either there is a network issue or the name or the tag of your image is not correct. Okay, so you need to double check, because sometime what will happen, you have given the correct name, and for some reason the image has been actually deleted. Okay, that could be another problem that can happen. So that's where when the name of the image or the tag, or if it is not able to find that image or the tag, then you will be getting this issue. And this happens during your container creating state. Okay, so if you look, the pod is in the phase called container creation, because only when it finds the image, downloads and creates the container, the next state will go to running. If not, it is still under container creating. Okay, now this is one scenario. All right, now let me just delete it. Now let's look at the next scenario, which is invalid registry credentials. Now technically, when you are having a private registry, then Kubernetes will try to connect to your private registry, and then it will try to download. Maybe the name of the image is correct, the tag is correct, network is correct, but you don't have the correct credentials to download. Okay, or you have given a wrong credentials. Anything can be there. Someone has made the image in the registry as read only, wherein you are not able to download. So in those scenarios also, where if Kubernetes is not able to communicate to the registry because of permissions or because of wrong credentials, even then the Kubernetes will be giving you the same image pullback message. Okay, now to understand this technically, let me go back to Docker Hub. Now this time I'm just using Docker Hub to just show you quickly. However, instead of that, you can try with any of your private registry like ECR on AWS also. Now assume this is a private registry, which is in fact, now I have logged in using my name, and this is a private registry, and you can see there are so many images that I am maintaining in my private registry. So if I want to download any one of them here, then I need to make sure that in your machine, you should be doing a Docker login against this registry, which is the private registry, because even though Docker Hub is public, I have created an account, then it becomes private. So if I try to download this image, then I need to make sure I have a proper Docker login credentials. Okay. Now, just to show you that, here, probably let me take this. Okay, so I have a application image called as Wezva CI/CD. So let's assume I want to download this. Okay, now before I run, if I just say Docker login, okay, now if I don't tell the registry, we know it will always go to Docker Hub. However, if you have a specific registry, you can define where you want to download it from. Okay, now here, if I give my credentials, if I give a proper credentials, it will log in. And now here, if I just say Docker pull and this image, you can see it works fine. Okay, so there is no problem here. But the same thing now, if you are having a private registry, then how will you tell Kubernetes to download from here? Now that is where in Kubernetes you will be using secrets. Okay, so with the help of a secret, you need to give the same credentials and you need to tell the registry. And when you are trying to define your pod or the manifest, in that you have to tell what is the secret object which has the credentials. So if the secret object has the correct credentials or the right permissions for your registry, then Kubernetes will be able to download. If not, it will give an error. To show you that, what I will now do is a couple of things. So first, let me delete this image. Okay, and whenever you do a Docker login, there will be a file created under a Docker folder, and there is a file called config.json. This is where the credentials will be stored. So I will delete this so that when I run this example, I want Kubernetes to pick from the secrets. Okay, now this is where what I'm going to do is I have already created a secret. Okay, now this secret points to the same dockerhub.com. However, I have given a wrong credential. Okay, so what will happen now when I try to create a new pod, I will say try to use this credential through the secret and then try to download the same image which I showed you manually. At that time, because Kubernetes will not be able to get the right credentials or permission issue, you will get the same image pullback message. Now for this, let me show you how to do. Now this is where in Kubernetes, if you want to download an image from a private registry, first create a secret object, and that is what you are going to give here. So in this example, you can see I'm trying to tell the image that I need is ADAM-WezvaTech CI/CD, but from where should I download? What credentials should I use? That I'm trying to give using an additional keyword. But for the demo purpose, what I have done, I have given a wrong credential in this. Okay, so now when I apply this, Kubernetes will try to read the secret, but there is a wrong credential. Because of that, the same image will not be able to download by Kubernetes. Okay, so once again, go back and I'll say pod watch, and let's say kubectl apply -f, and then registry credentials. So once again, you should see that pending container creating and error image, because this time credentials is not proper. So if you go here and say kubectl describe pod and the pod name, again you should say very clearly, it says that where is it trying to connect. You can see using my secret object, I have told to go to Docker Hub. Now in this, it is trying to tell I am not able to connect to my private registry in Docker Hub because either I don't have permissions or the username and password is not correct. So this is where when you get this kind of message, what you need to know is cross-check whether the tag name or the image name is proper, or the image in the registry is available, or you have proper credentials to access the registry from Kubernetes. So when I say you have, Kubernetes have, and for that, have you created a proper secret object and have you given the credentials? Okay, so that's the next thing that you have to check. Okay, so this is how what we are going to do is debug and analyze one by one. Now anyway, there are a couple of more things that we have to cover, but again, this is what we will be doing as part of tomorrow's sessions. So we will continue understanding what are the different other scenarios that we have to debug. Okay, so but for now, let me stop the session, and if there's any questions, please stay back. Thank you.